Hi, I'm David. I'm the coordinator of the Maths Learning Centre here at the Uni of Adelaide, and I'm about to do some worked examples involving series and power series and Taylor series. All right, this one says decide whether the series converges and find its value if it does converge. And I've got the sum from n equals 0 to infinity of 2ln3 all to the power of n divided by n factorial. Okay, well, what I'd normally do when I try to see if a series converges is I would compare it to a series that I'm familiar with first, and hopefully it's one of those. And if it's not, then I would try and do some sort of series convergence test, like the ratio test or something. Well, the series that I am familiar with are the harmonic series, which would be 1 over n just n, and so that's not right. There is one that I do know with an n factorial in it, and that's the Taylor series for e to the power of x. So let me have a look at that. E to the power of x is the sum from n equals 0 to infinity of x to the power of n over n factorial, and this works no matter what x is. Okay, well, that's what I've got. I've got thing to the power of n over n factorial, so this must be e to the power of whatever that number is. So this is e to the power of 2ln3. Awesome. I could stop there, but the fact there's an e and an ln means that something should sort of wipe each other out. So I reckon I'm going to just see if I can deal with that. I guess that's the same as 2ln, e to the ln3 times 2, which is the same as e to the ln3 squared. And ln is designed so that e to the power of ln of number is the number itself. So that's 3 squared, and that's 9. All right, so it does converge, and that's the answer. All right, cool. Let me have a look at the next one. Find the value of the following geometric series. Okay, they've told me it's a geometric series, which is good. They've told me to find the value, so I'm assuming it converges. Okay, now a geometric series, I know a formula for the value of it, and the formula I know is this, that if I have n equals 0 to infinity of x to the power of n, then that is 1 over 1 minus x. So comparing that to this, I do have a whole lot of powers. So if I can combine them somehow into a single power of a number x, then I should be able to do it. And it doesn't start at 0, it starts at 5, so I have to deal with that too. Well, let me get started and see what happens. Okay, well, the j plus 1, to make it just be the same power as this letter here, the j, then I'm going to need to go something like this maybe. 3 to the j plus 1 is the same as 3 to the j times 3 to the 1. And that'll give me a power of j, just like this has a power of n, so I reckon that'll be good. And 2 to the power of 2j, if I did this, that's the same as 2 to the power of 2, then to the power of j, and now I've got a single power of j, like a single exponent with j, so that's good. Okay. All right, so that's 3 to the power of j. 2 squared is 4, so that's 4 to the power of j. I don't like that 3, but if it really does converge, then multiplying by all of the individual terms by 3 will be the same as multiplying the whole series by 3 afterwards, so I can do that. And powers interact with division by the exponent coming out, so I can do this. Like that. Okay, that's looking pretty good. This is my x for this formula here. So 3/4 to the j. So if it did start at 0, I'd be able to go 1 over 1 minus x, but it doesn't start at 0. So I guess I could figure out what it would be if it did start at 0 and take off the first 4, like the j equals 0, 1, 2, 3, and 4. So that's the first 5 actually. Or I could try and adjust this so it did start at 0. I reckon that's what I'm going to do. So if I wanted that to start at 0 and I still want it to come out to the same answer, then I could do j plus 5 up here. And then when j is 0, this thing works out to 5, which is the same thing as starting with j equals 5 here. And then when j is 1, this works out to 6, which is the second one of these. So it works out to be the same list of numbers overall added together. So that should be okay. And then I'll just have to do exactly the same trick I did before of that's 3/4 to the j times 3/4 to the 5. And so I've got 3 times 3/4 to the 5, j equals 0 to infinity, 3/4 to the j. And that I have a formula for. So I've sort of run out of space on this page, so I'm going to stick it over here. So that is equal to 3 times 3/4 to the 5 times 1 over 1 minus 3/4, which is how this works. And I'm feeling good because 3/4 is less than 1, and this formula only works if x is less than 1. So that's good. Feeling all right about that. I don't like fractions within fractions. So if I multiply this and this by 4, that'll get rid of that fraction within a fraction. 4 over 4 minus 3. Oh, that's cool. And so I've got 3 times 3/4 to the 5 times 4 over 1, which is 4. Maybe I'll just leave it like that. Oh, maybe not. So that power of 5 can apply to both. So I've got 3 times 3 to the power of 5 times 4 over 4 to the power of 5, which is 3 to the power of 6 over 4 to the power of 4, which is not too bad. I don't know what 3 to the power of 6 is off the top of my head. I'd need a calculator for that. Let me see. $729 and 256. Cool. Probably would have been okay if this was an exam. If I had stopped maybe here, that would have been okay, I reckon. Yeah. Anyway, I do have a value. Looks like it's a bit more than 3. All right. Let me try the next one. Suppose the sum from n equals 0 to infinity of an times x to the power of n is a power series such that the limit as n goes to infinity of the absolute value of an plus 1 over an is 2. What is the radius of convergence of the power series? Okay. Let me just think about that. A power series has, okay, what is the radius of convergence? That would mean there's a set of x's for which this definitely converges. And that set of x's is called the radius, the interval of convergence, and the width of that is the radius of convergence. And I would normally find that by doing the ratio test on this. And so I do the n plus 1th term of this divided by the nth term of this and the absolute value of that. And I'd figure that out, and then I do the limit of that, and that should tell me things. So let's see. Well, absolute values allow me to do this. And then powers allow me to do this. So x to the n plus 1 divided by x to the n is just the same as x. Okay. And then I have to do the limit of that as n goes to infinity. which is the same as, because that absolute value of x doesn't have an n in it. And they told me that that limit is 2, so that would be 2 times the absolute value of x. And when I do the ratio test, if this limit comes out to be less than 1, then the series definitely converges. And if it's greater than 1, then it definitely diverges. So that'll give me a little zone based on x. So it converges when that is less than 1, which means the absolute value of x is less than 1/2. And that's giving me a zone from -1/2 to +1/2. It might actually converge at one or both of these ends, but in terms of the width of that interval is 1 wide, and the radius from the center to the edge is 1/2. So at this stage, I would know that the radius of convergence is 1/2. And probably technically I wouldn't need to do all that work because it would always work out this way, that 1 over this thing would work out to be the radius of convergence. But I feel more comfortable having done it this way. All right, what's the next one? Find the first 4 terms of the Taylor series for f of x is equal to the function x minus 4 divided by x plus 6 about x equals 2. Okay. So when I do a Taylor series about x equals 2, I'll be rewriting f of x as a0 plus a1 x minus 2 plus a2 x minus 2 squared plus a3 x minus 2 cubed, etc. And they would be the first 4 terms. And these numbers here would be chosen based on the derivative of f. So a0 would be f of this center 2, which would be 2 minus 4 over 2 plus 6, which is -2 over 8, which is -1/4. Okay. And a1 will be f dashed of 2. So first I'm going to need to know what f dashed of x is. Okay. I don't like that function. I mean, I'm going to have to do all this quotient rule stuff. So I feel like I want to rewrite that function in a better way. So let's see, f of x is x minus 4 over x plus 6. If there was an x plus 6 on the top, then it could, divide out with the x plus 6 on the bottom, and I wouldn't have so many x's. So what if I put it there, put an x plus 6 and an x and a minus 6 in, so that I haven't actually changed anything, but it looks different. And so that's going to be x plus 6 minus 10 over x plus 6. And then x plus 6 divided by x plus 6 is 1. And then I'll have minus 10 over x plus 6. Yes, that's nice. I like it. I reckon for the purposes of differentiating, it'll be easier to write it as a power. Okay, so f dashed of x is now derivative of 1 is 1. The minus 10 will still be there. I have to multiply by the current exponent and then put the exponent down by 1 and then multiply by the derivative of x plus 6, which is 1 anyway. Cool. So that's 10 over x plus 6 to the minus 2. And a1 is f dashed of the center over 1 factorial. And this, so we've got 10 of 2 plus 6 to the minus 2 over 1, which is 10 over 8 squared. I'm just going to leave it like that. All right, to figure out a2, I'm going to need f double dashed of x, which according to this would be 10 times the current exponent, x plus 6 to the minus 3, which is 20, x plus 6 to the minus 3. Okay. And f double dashed of 2 would be 22 plus 6 to the minus 3, which is 20 over 8 cubed, whatever that is. 12. And so A2 is f double dash of 2 divided by 2 factorial, because that's how Taylor series work. And so that will be 20 over 512 divided by 2, because 2 factorial is 2. And so that'll be 10 over 512. Okay, run out of paper. I'm just going to need some more, which will have to be yellow because that's the only paper I have. Now, f triple dashed of x is, where was f dash double dash here? 20. 20 times minus 3 x plus 6 to the minus 4. And f triple dashed, so I guess that's minus 60 x plus 6. Oh, crap. That was supposed to be a minus back here. Minus, 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 minus. Okay. So that's actually a minus 20. That's a plus 60 now. Okay. So f triple dashed of 2, because that's the center, is 60 times 2 plus 6 to the minus 4, which is 60 on 8 to the power of 4. 6. And then A3 would be f triple dash of 2 over 3 factorial, which is 60 on 4096 divided by 6, because that's what 3 factorial is, which is 10 on 4096. And so therefore the first 4 terms are, where did that go? Minus a quarter plus 10 on 64 x minus 2 minus 10 on 512 x minus 2 squared plus 10 on 4096 x minus 2 cubed, and then there's the rest, but they didn't ask for that. And I probably should have simplified these because 2 goes into both 10 and 64, but I can't be bothered. So I'm just going to leave it like that. All right. What's my next problem? The radius of convergence for the following power series is 3. Okay, so I'm just going to trust them on that. Find its interval of convergence. Okay, well, let's have a look. The center, because it's just x and it's not x minus 3 or x plus 4 or something, the center is 0. And the radius is 3, which means it must go from 0 up 3, which is 3, and down 3, which is minus 3. So the interval contains everything from minus 3 to plus 3, because that's how intervals of convergence work. It's a radius that goes from a center. So the question is whether it converges at these endpoints or not, and that's what I'm going to have to figure out. So when x is equal to minus 3, the series is n equals 0 to infinity, minus 1 to the n, 3 to the n over 3 to the n, 2n plus 5. And then they'll divide away. And so I'll be left with the sum from n equals 0 to infinity of minus 1 to the n over 2n plus 5. And now as n gets bigger, this gets bigger. And so the fraction 1 over 2n plus 5 gets smaller and smaller. And so because that gets definitely decreasing and it's alternating series, this converges. Okay, so it's definitely, it converges there. And if x equals minus 3 plus 3, oh crap. That's what happened at plus 3. I didn't put minus 3 in, I'll just change it. And so, damn it. It was this n that I did first, sorry. Plus 3 makes that a plus 3 to the n. Okay. So now let's actually do what happens at minus 3. At minus 3, the series is n equals 0 to infinity minus 1 to the n of minus 3 to the n, 3 to the n. Okay, but minus 3 to the n, like minus 1 to the n, minus 3 to the n, the way that powers interact with multiplication is that I can bring the exponent out. So that's minus 3 to the n. Okay, so that's n equals 0 to infinity of 1 to the n, of 3 to the n divided by 3 to the n, and that is 1. All right, that's a harmonic series. If it had just been an n, then it would have definitely been the harmonic series, and I would have been able to, well, yeah, maybe not starting at 0, but if it had just been an n, it would have been the harmonic series, and I would know that it definitely does not converge. But anything that has a linear on the bottom also doesn't converge. So this is does not converge since a harmonic series. Okay, and so it doesn't converge when x is minus 3, and it does converge when x is 3. So therefore, the interval of convergence is from minus 3 to 3, and it's a round bracket here because it doesn't include minus 3, and it's a square bracket here because it does include 3. Awesome. Last one, let's have a look. Suppose the following power series converges when x equals 3, but does not converge when x equals 7 over 2. 7 over 2 is 3.5. Okay. And it's called okay, we've got the interval when k equals 0 to infinity of bn x minus 1 to the n. Oh, I think those letters are supposed to actually match. I'm going to change this to a k and presume that that's what we meant. Okay. All right, so bk is like some sort of number. So it's a power series x minus 1 to the k. So the center is at 1. Okay. So the set of all the x's where that makes it converge is an interval, and it's called the interval of convergence. And it would be, it has a center at 1 because of this, and it goes from, well, somewhere to somewhere else, and I don't know, but it's definitely interval with center 1. And it goes up to somewhere, and I know that x equals 3 is part of it, and x equals 3.5 is not. Okay, I might write this 3.5 because mathematicians don't like mixed numbers. Okay, so I know that the interval has center 1, and it definitely goes up to 3, which means it's definitely going to go down to 2, 3, 0, minus 1. So everything from here to here is definitely converging, and it definitely does not converge at 3.5. Okay, so everything after that, it's going to not converge here. And so when we go down 3.5, 1, 2, 3.5 minus 2.5, it definitely doesn't converge here. But I don't know what's happening in between. It could go all the way up to 3.5 and just not converge at the very edge there. Could go all the way down to minus 2.5, and it could converge, and it could even converge at minus 2.5 because it's allowed to converge at one end but not the other. Okay, so let's see. X equals 2 is definitely inside the interval of convergence, so it converges here. B, x equals 1, well, that's the center. It definitely converges there. Because if you sub in x equals 1, the whole thing is just 0. When x equals 0, definitely inside the interval of convergence. X equals minus 1, not sure. It does converge when x is 3, but if the interval of convergence just went to x equals 3 and that was the end of it, then it would technically be allowed to not converge at that end. So when x equals minus 1, not enough information. And the lastly, when x is minus 2, one, two, three, also not enough information. All right, cool. But I definitely know it doesn't converge for anything after 3.5 and anything below minus 2.5. What an interesting question. Okay, well, I'm going to stop there. Thanks for watching.